In this lesson we're going to continue to look at redox reactions. This time we're going to extend the definition of a redox reaction. In the last lesson we said that oxidation was where an element gained oxygen and reduction was where it lost oxygen. Now in this more general and more useful definition we talk about oxidation and reduction in terms of electron transfer. So we can say when oxidation takes place that electrons are lost. Okay, so we'll put lose electrons, while when reduction takes place electrons are gained. So in reduction we gain electrons. So when oxidation takes place then the oxidation state or oxidation number increases, while when reduction takes place then the oxidation state or number decreases. So to help us understand this a little bit better, let's just take a look at a typical redox reaction, which will be a displacement reaction, one that you will all have seen, which is the displacement of aqueous copper ions by zinc metal. And you can see this reaction in the practical demos section where, for example, a galvanized screw is inserted into a solution of copper sulfate, and gradually a layer of copper appears on the surface of the zinc plated screw, and the light blue coloration of the copper 2 sulfate solution slowly changes to clear as a solution of zinc sulfate forms. So to see what's happening clearly in terms of loss and gain of electrons, let's look at the ionization equation for this reaction. So in this reaction you can see that the copper 2 plus ions are gaining electrons from the zinc and forming copper atom. They're having their oxidation state reduced, so we say that because they are gaining electrons that the copper 2 plus ion is being reduced. Alright, so we've got reduction happening here. The copper 2 plus gains 2 electrons to form the copper atom. Likewise, we've got oxidation occurring here where the zinc gives up its electrons to form a zinc 2 plus ion in aqueous solution. So the zinc is losing electrons, and by our new definition at the top here, that means that oxidation is taking place. Now before I continue, let's just make a bit of space and move this over here. And also I should have put here that this is an aqueous solution of copper 2 sulfate, and also that the zinc sulfate is aqueous. Okay, and just going back to this ionization equation, what we can see is that the copper 2 plus ion is being reduced, so the zinc is acting as a reducing agent, while the zinc is being oxidized. It's having its oxidization number increased, so the aqueous copper 2 plus ion is acting as an oxidizing agent. And this is the case in all redox reactions. There is always oxidation taking place and reduction, and at the same time there's always a reducing agent and an oxidizing agent. Okay, so let's just compare the reducing and oxidizing power of the metals and their aqueous metal ions in the reactivity series. We can talk about the metals as being reducing agents. They want to lose electrons to form aqueous metal ions, and their ability to do that decreases as you move down the reactivity series. So we can say that they are reducing agents and their reducing power decreases as we move down the series. That's to say their ability to lose their valency electrons to form an ion. Conversely, the aqueous metal ions act as oxidizing agents rather than reducing agents. Their oxidizing power increases as you move down the group rather than decreases. That means as we move down the group, the aqueous ions find it easier to receive electrons and so to be reduced. So if you want to see a very aggressive reaction, then you would mix a metal which is a powerful reducing agent, that's a metal at the high end of the reactivity series, with an aqueous ion that is a powerful oxidizing agent. For example, if you were to add potassium to a solution of silver nitrate, then because potassium is such a powerful reducing agent and the aqueous silver ion is a powerful oxidizing agent, you would get a very aggressive, explosive and dangerous reaction. So you should never even try that. As a general rule, aggressive or explosive reactions will occur when powerful reducing agents are combined with powerful oxidizing agents.